Today, we have Archana Vaidheeswaran for one of the most iconic topic, large language model organized by women who code data science community. LLM is a deep learning technique that benefits diverse industries with its intrinsic application perspective by pre-training and fine-tuning. This is a 5-part series with in-depth focused 1-hour session for each week starting today for the next 4 weeks to sharpen your skills in LLM. This is a collection of progressive skill building happening with today's opening session with the introduction of LLM. And on June 13th, the session 2 focuses on fine-tuning LLM with specific AI algorithmic pre-trained and fine-tuning methodology. And in session 3, that happens on June 20th, we are getting into the elaboration of prompt engineering, focusing on crafting optimal textual input. And on session 4, which is happening on June 27th, we have the information of the advanced applications and custom LLM, which would get us into the final session that's going to happen on July 4th, retrospecting our learnings, knowing the actual industry application with one of our senior industry expert, Archana. So let's join together to welcome our speaker of today, Archana Vaidheeswaran. Archana Vaidheeswaran is a data product manager at Women Who Code and a passionate advocate for women in technology. She is recognized as a fellow by the Python Software Foundation for her commitment to leverage Python in AI and data science. She has delivered engaging talks at conferences like FOSS Asia, Women Who Code Connect, and Scipy 2023. She holds a broad perspective of the role of AI and data science across various sectors. She has experience leading a thriving community of Python enthusiasts as a Women Who Code Leadership Fellow and is here today to navigate us into the complex world of LLM. So let's get started into the session without further delay. Over to you, Archana.
Thank you so much, Kirthikka, for such a wonderful introduction. And yeah, I'll go ahead and share my screen. Okay, awesome. Yeah. Are you able to see my screen?
Yes.
Oh, awesome. So hi, everyone. Thank you so much for joining in today. I know it must be like super early or super late for some of you. So yeah, thank you for joining from wherever you're joining, and thank you for taking out this time today. It's as Kirthikka said, I've had quite a bit of experience with data science and machine learning as such, and I think everyone would have heard a bit of GPT. I think like GPT has become now like I would say so far to say like a household name where people are using it extensively. But there's so much that happens behind the screens, right? Like, why did GPT come the way that it is today? And, I wanted to also introduce here Soham. He's also, working with me to publish this newsletter that we've been talking about. Like, we've been working on LLMs for a long time now, and we actively talk about it. But something we realized is that people don't realize how far we have come along. And so for like my personal goal through this presentation or through the study group is to make sure that, our community, especially at Women Who Code, is able to understand LLMs. And most importantly, when we hear buzzwords, and which we are likely to hear in the next, few months or years to come, we are able to get the context of what's happening, right? So, we are trying to make it very beginner friendly, trying to make something that you can actually take away. And so if you're coming to this presentation, what are the goals here? Firstly, trying to learn how, stuff like ChatGPT happened, right? Like, what are these large language models? And, I'm not talking about anything new here. I'll be talking about things that people have talked about before, but I'll just try to compress it and make sure it's like as beginner friendly as possible, right? So that everyone is able to take something away. And secondly, understand terminologies. I know like when you read like an article or like if you do have a time a research paper, you're going to come across like terminologies, right? And so yeah, I'm going to make sure you understand those terminologies. So that's another thing that is going to happen today, is being able to understand those terminologies on LLMs. And finally, understand the basic pipeline of GPT. So in this particular introduction, we're going to get started with the basic pipeline of GPT. And how I'm doing that is also using this really nice talk by Andrej Karpathy, who has, I think he recently or maybe in the last year or so joined in at OpenAI. And so he has a great talk called State of GPT that was released a few weeks ago. It's very well done. And I've just tried to encapsulate some of it in our session today as well. And I'll put in the link so that you can also go check it out. It's a pretty long talk. So I don't know if you're on transport or going somewhere, maybe office, or I don't know. It's like 40 minutes. So you have to like best to listen to it, when you are going somewhere. But he has given a pretty good talk about that. So yeah, and one more thing that I'm going to do is make sure it's as accessible to you as possible. So whatever I'm talking about today is on the slides. I've made sure I don't talk outside that context, to make sure that, in case like something gets left out because of language barrier or anything, I want to make sure that all the content is out there for you to see. So yeah, now that I've sort of laid the ground and maybe got you excited about LLMs, let me introduce the topic, right? And as any introduction goes, I want to talk about something very simple here, right? Like what is LLM? But before we move into LLMs, how did it come about being so, right? So first, like a little like very quick introduction into neural nets, because I don't know the sort of audience we have. We might have like a diverse set of audience, those who do not know neural nets but want a precursor. So this is a good precursor. So neural nets, as you know, have like 3 layers. They have an input layer. So this layer receives various forms of information from outside world, and this is the only part of the network that's exposed to the given data. And then there's a hidden layer. There are computational layers that take in information from the input and then perform some operations on it to influence the data that will be accepted by the output layer. And finally, you have the output layer, which is the final layer of the neural network. And it helps to, either you have like stuff like probability that's designed in terms of classification. So like, if you have like a cat and a dog picture and you send in a cat picture, it assigns maybe a higher probability to the cat versus the dog. And so the network knows, oh, it's a cat, right? So, so one such network is actually RNNs. So what do RNNs do, right? So RNNs are recurrent neural networks. So they process data sequentially, which was like very useful in tasks that required context over time, like translating a sentence. So I remember like way back, translation was purely run on RNNs. But what was the difficulty with RNNs? They had difficulty in maintaining context over long sequences, and they required a longer time to train. So people also were like, I don't know if you know this word, but CNNs are basically convolutional neural networks. They were traditionally used for image processing, like I explained the dog cat example. That would be like a perfect example for CNNs, where it would classify whether it's a dog or a cat. But CNNs were also used for sequential data. So they processed input data in parallel, making them more faster and more scalable than RNNs. But they were also not good at capturing temporal dependencies. So this brings us to tokenization. And this is a very fun word. This is something you're going to hear quite often. People are going to be like, oh, this particular model has these many tokens, or that particular model has that many tokens. So this particular information here is quite important. So both RNNs and CNNs involves significant data processing. So this is where tokenization comes in play. So tokenization is the process of splitting a sentence into individual words or character tokens. It's like chopping a sentence into pieces so the model can look at each piece one by one. So I've used this image on your right hand side of your screen, if you can see. This is again by the talk I was mentioning by the State of GPT. And what it does here is, the word is like, here it says GPT family of models process text using tokens, right? And what you can see is there's an encoding done of this, right? It changes this into tokens, into integers. And so the raw text is changed into tokens, and the tokens are further changed into integers. So this is what tokenization is. It's breaking it up and making it more sensible to, you would say, like, computers as such, right? And so this is where you had stuff like transformers come in. And why I'm giving you all this history is that people are going to repeat it over and over again, and people are going to take, like, instances from it and actually use it going forward, right? So that's why we are including it over and over again. So so basically this is a very famous paper, and this called Attention is All You Need, and it introduced this model called transformers. And transformers was a major breakthrough. I didn't catch that. Sorry, my Siri got on somehow, but yeah. So transformer is a model which had a major breakthrough, as it could process all tokens in input data in parallel while also maintaining a sense of order like RNNs. So, okay, so what is transformer doing, right? It's paying attention to different words. So what I mean by that is, let us look at this sentence, right? I took my dog for a dash. What would a dash be, right? And again, like, I want this session to be a bit more like, interactive. So feel free to use the chat and say, like, what should the model, like, first of all, what would you fill in the dash? Right. Yeah, great. Thank you, Megan. It's, a walk. That's great. So when you said it's a walk, what do you think you paid more attention to? And what should, like, the model pay more attention to? Right? Which part of the sentence, like which words in particular? Again, and like, feel free to use the chat, and we're all learning here, so feel free to learn as much as possible. So so let us look at what I mean by that. So firstly, what the model should pay attention for is like dog and for, because that's what is required for writing a walk. And probably it shouldn't pay attention to stuff like I and my words, right? So this is exactly what a transformer is doing, and that is exactly what the paper got forward. It got forward that, there were two main takeaways. Firstly was attention to different words changes the importance. So the model is able to look at specific words and pay attention to the words that is needed for guessing the next word. And secondly, what is another thing is the positional encoding. Now, what is this fancy term, right? So positional encoding is basically understand how the sentence is structured. So again and again, I was explaining RNNs. I was like, it takes in sequence of words, right? A sequence of words means you have to make sure it's structurally the same, right? So, and the structure of the word matters and the order of the words matter, because you don't want the model to say stuff like, I feed my dog cat food, right? That would be completely wrong. But why that would happen is that the structure of words weren't right. So something like that is where positional encoding comes into play. So these are the two main takeaways of the transformer paper. And one thing that really surprises me about this field is that this paper is, I would say, relatively new, right? Like, I mean, it's less than 5 years old, and like 2017 or something. So I mean, if you think about it, like 5 to 6 years old. So yeah, if you think about it, this field like rapidly changed from models looking at words and trying to guess the next word into making like logical sentences. And clearly something pushed us that way, right? And that is what we're trying to discover today, like where it was and why it has become the way it has today. So yeah, so in 2018, OpenAI introduced its first like generative pre-trained transformer. And today you have like GPT-4. That was the first GPT. It was trained on a large corpus of text from the internet in an unsupervised manner, meaning it learned to predict the next word in the sentence without explicit instruction. And so GPT was a transformer decoder model, meaning it was designed to generate text. It used attention mechanism, which we previously talked about, to consider all prior words in the generated text when predicting the next word. So I think this is like the most important fact, that your LLM or your GPT will always try to guess the next word. And I'm going to like repeat this over and over again. And why so is that it'll help you later on when you're building models and also when you're interacting with GPT, right? I think like when I actually saw the video, I realized more things about how to interact with GPT. And that I think is the biggest takeaway as well, because I know how the models work underneath, I can interact with it better. So I think if nothing, you should take that away for sure, is that in general, they are just trying to guess the next word. So it's allowed to generate a coherent and contextually relevant sentences. So yeah. Now I want to introduce you to terminologies as such. Let me check if there are any questions.
There is one question which is posted by Yagni Carman. So
Yeah,
let me
yeah.
read out the question for you. Does
Sure.
the input data need to be cleaned and transformed before entering the network?
So yes, in some cases, it does need to be like, I'll answer it live. Yeah. So it does need to be cleaned and transformed. But today what we're looking at is where did they get the data from? Some data sets are cleaned and transformed already. And it just depends on where they crawl data. Now, every LLM does it differently. For example, GPT crawled it on the internet. So not all of it could be cleaned and transformed. But I think like it just depends in terms of the LLMs you're using. And yeah. And yes, Soham, feel free to add anything that you want and maybe, answer the questions too if you have the time. But yeah, thank you. Let me go ahead. So some terminologies that you might come across. This is again, when you're reading like a paper out there, you might come across more terminologies and you might be like, oh, what does that mean? And they're going to be like repeated, like, alternatively. And so I want you to also take that away, like, what do these terminologies mean? First one is parameters. So what do they mean when they say parameters? So in AI models, parameters are the parts of the model that are learned from historically training data. So they are the knobs that the models tweak to get better at its task. In the GPT series, the number of parameters grew from 117 million in GPT to a whopping 175 billion in GPT-3. And so you have to realize like how big the model gets, right? Like how big, like even the model's parameters get, right? The historical training data get. So if it was like a small town's population in GPT-1, it's almost like double the population of, I don't know, twice 2 Earths, right? So in GPT-3, so that's how much the module of the model as such is like so much bigger because it's being trained on so many more parameters. And then comes vocabulary size. So this is again something that people are going to repeat over and over again. So this refers to the number of unique tokens the model knows. It's like a personal dictionary. The larger the vocabulary size, the more nuanced and varied the language model can understand and generate. So imagine like having a dictionary that instead of a few thousand words contains tens of thousands of words. So that's a really big dictionary, right? Very, very big vocabulary as such. And then we have fine tuning. So this, I think, if you have worked with like, transfer learning before, you would have also heard this term. So fine tuning is basically making these large models or models like GPT-3 to be pre-trained on a, which are like pre-trained on a very large data set to be actually fine-tuned for something very specific. And what I would say, like, if you want to understand fine tuning is that imagine like someone is graduating from, college and they want to go into medical school. So what do? They get a specialization in being a, like in medicine, right? So that's being like, even though they had a lot of knowledge before, this is like much more specific. And that's like something maybe like similar to what models do. And then, yeah, the next is few shot learning. This refers to the model's ability to understand a task given only a few examples. So let us say you have this super smart alien trying to, who's given like a few examples of what a bicycle is, like these are the parts, and then you're being asking to build one. So you just given it like very few examples, and then you're asking it to build something like really good with it. So that is what GPT is good at. Given these small few short learning tasks, it was able to make like better creative sentence, and that's what made it so much exciting. And then you have context length, right? So this is another thing that people are going to use often. They're going to be like, oh, this model has this much context length. So context length just refers to the amount of the recent input that the model can remember to produce the output. So I would say like a fun way to remember what context length is trying to have a conversation with Dory, right? So if you've watched Finding Nemo, Dory is this very forgetful fish. So after a few rounds of swimming, Dory forgets what you said, right? So similar to that, the context length is the number of laps the model can remember. The longer the context length, the better the model can keep track of long documents or conversations. And so for instance, like they would say like, okay, GPT-3 can pay attention to about 2048 tokens at a time. So tokens, if anyone remembers, is basically taking a sentence and then breaking into parts like characters or words. So we say, okay, like they said, okay, GPT-3 can pay attention to 2048 tokens at a time. So this is like, if we were talking in terms of the English language, this is approximately a few pages of a book. Anything beyond this, GPT-3 might start to lose track. It's a bit like your model has a short-term memory and it can only keep so many pieces of information in mind at once. Okay, so this brings us to the rise of GPT-2. So why I stopped in the middle and sort of took a plunge into terminologies as such was to make you understand that, okay, I'm going to repeat some of these words now, and I hope you remember what it is. So firstly is GPT-2. It was actually, it had like 1.5 billion parameters. So what does that mean? I don't know if anyone remembers what I said about parameters. Let me go back here. Does anyone remember parameters? It's okay even if you want me to go back and look at it. Again, feel free to let me know. Okay, awesome. People do remember parameters. You can go ahead and put it in the chat if you do. Yes, the knobs that you can turn. Awesome, Francis. Thank you so much, Francis and Megan and you. Yes, the knobs that are used to tweak the models. So it's around 1.5 billion knobs to be certain. So yeah, the model is way better. So now let us move to GPT-3. So the GPT-3 actually had 175 billion parameters. So it was like way better in size and it was contextually more accurate text. And so let us look at this example, and this is very interesting. And this is something that Karpathy also covered in his talk. So he talks about why do he talks about these two models. So we don't know a lot about GPT-4 because it's not open source. So you don't, let us talk about GPT-3 here. So GPT-3 actually has 50,257 vocabulary size. So vocabulary size is something, again, I covered. So it's like basically a dictionary, right? And 2048 context length and 175 billion parameters, as I said. And Llama is another model, which is also a large language model by Meta. It has 32,000 vocabulary size, 2048 context length, and 65 billion parameters. Now, surprisingly, Llama is known to perform better than GPT-3. Can anyone guess why is the case? And feel free to Google it, on, I don't know, ask GPT again, but yeah, whatever you prefer. But yeah, can someone guess why is it more recent? Yeah, that is true. But there's another reason why it is a bit better. Feel free to Google it. It'll help you in later, maybe even refining your searches when you search about LLMs. So what we're trying to see here is that, GPT-3 only has GPT-3 actually has 50,257 vocabulary size, but Llama has 32,000 vocabulary size only. So, but if you compare it, and so Llama should have like a smaller vocabulary size. It does not have a lot of parameters. So it's like 175 billion and this has only 65 billion. So like, what are we missing? How is Llama still performing better? So yeah, thank you so much. Such amazing answers. So turns out when you dig a little deeper, and this is why I asked you to Google, because this is not information you had before, was the fact that Llama was actually trained on 1.4 trillion tokens. And GPT was only trained on 300 billion tokens. So if you compare the numbers, we realize that Llama was actually trained on much more bigger tokens. And so it is actually performing way better than GPT-3. And so let us now see like why so. Why is that LLMs are different than human brains, and how do they like approach a problem, right? And I think like this has been like very eye-opening for me in general, because I am also someone who has been using GPT, and sometimes, you know, you might not use the right sort of prompts to get out of it, and you wonder, you know, why does it behave the way it does? And I think this was very interesting as such. So let us like try to understand LLMs, right? Firstly, LLMs, what they're trying to do is predict the next word in the sentence. So they're solely relying on patterns found in the text data they have been trained on. They don't understand text in the way humans do, and they don't have emotions or consciousness. But a human brain is a multi-dimensional network processing emotions, visual, sound, taste, and more. Our decisions and actions are based not only on logic, but on feelings and emotions. We learn from experiences and adapt over time, but we are also biased and can also make mistakes. Not to say LLMs can't make mistakes, but this is where we'll understand like how we approach a problem versus how LLMs do. So yeah, I have a very interesting problem here, very simple, right? Like, okay, again, like a bit of Googling will be required. Someone will have to go check, but can you tell me, so this population of India, there's a population of the US. Now, population of India is how many times the population of the US? So can someone like go check on that? Again, you should be able to find this online, and it's very simple, but mostly what I'm trying to do is trying to gauge how you might be doing it to versus how LLMs might be doing it. And there is where like the, you know, like it'll make us understand why LLMs are different and why they're good at doing the things they do. Can someone come up with the answer? Again, feel free to use the internet. You're here to learn as much as possible. Awesome, 4 times. Thank you, Kirthikka. Yeah. 13, 4 to 5 times. Great. Yeah, so we already have a lot of numbers. So let us try to understand how did you go about doing so, right? So first thing you would have done is probably Googled India's population and then Googled like US population, right? So you found out Indian population is close to 1.408 billion as of 2021. And US population is 331.9 million as of 2021. Right? Then what you do is you look at this number. This is very large, right? And if I try to divide it, I think I've forgotten how many zeros are there in billion and millions. So I'm pretty sure I can't divide this. So what you do is you go to a calculator and you're like, okay, let me calculate how much this will be. And the calculator gives you 4.24. So then you like think, does this sound right? It was 1.4 billion and this was 331.9 million. So does it sound right? And you go like, yeah, it does sound. It was 4 to 5 times, which is the right answer that, you know, for few folks also gave us. So we realized, yeah, it is the right answer. And we write there, it is around 4.3 times the population of the US. So this is how we as humans approach the problem. Now, let us look at how LLMs will deal with it, right? So what LLMs do, which like something that, you know, has been repeated all along, is actually break them up into tokens, right? And what you have to understand here is that LLMs will deal with each tokens in the same way. So when it breaks the sentence up in tokens, it's going to use the same amount of compute on each token as well. So they will just try to imitate the next token. Given these sentence, what will be the next thing? So yeah, if you say population of India is how many times the US, it'll just try to imitate and try to understand the next token. But how does it come up with that very logical, you know, answer of 4.3 or something, right? So this is where then memory comes into play. Something that we don't have that the LLMs do is a very large memory and knowledge base. And that is why they are able to get the number 4.3. And what they don't have, what you have done, what they don't do is the fact that you have an internal monologue, right? You try to figure out, okay, I have these two numbers, where should I, firstly, like, where do I get these two numbers from? And then how do I calculate it? This is like an internal monologue going for how to logically approach this problem, right? They don't have that. And they don't have a sanity check. So when they're telling you 4.3, and if they tell you 6 times, or if they tell you 7 times the next time, they'll still say that confidently because they don't do a lot of sanity check. Maybe even like in the recent GPT-4, although if you do ask it to reflect back, it does do it and does try to go back and see if it has come to the right conclusion. But most of the times they'll confidently tell you the wrong answer as well, because they don't do that sanity check. So yeah, so what do we realize over here is that LLMs are really good at human-like text. They're really good at translation. They're really good at creativity and simplifying complex language models, like complex language as such. And then they're bad at handling ambiguity, guaranteeing truthfulness, and recognizing and responding to emotional states. And I think this makes like our prompting even better, because now we understand there are things that it is good at, but it will never be thinking the same way we are. It'll still come to a conclusion by imitating or just trying to guess the next token. And that's essentially what it's doing. So now this brings me towards like the last topic for today, which is LLM pipelines. Yeah. Okay. So what is a typical, let me see if we have any more questions, but yeah. So what does a typical model pipeline look like, right? So this is something that you would work with if you're working with machine learning directly, or trying to like, I think like people do it in small firms and larger firms. Obviously, like bigger organization have an entire ops built around this, but you would also do it if you were making tiny projects, right? It's scalable. It goes from a very small to people working in big organizations as well. So what do you essentially do when you start with something called data ingestion before? And I think someone mentioned it is, you take the data and make sure it has versioning, and then you take data validation, where you validate if the data is right. And then you do data pre-processing, as someone said, you figure out and you clean the data as such. And then you do model training, and then you do something called model tuning. So what does that mean? So model tuning is again like what we talked about, fine tuning. You take the data and a pre-trained model, like for example GPT-3, and you tune it on some specific task. So that's model tuning. And then you do model analysis, and then you validate the model again. Is it actually doing well? And then you deploy it. So deployment can be to an endpoint like a website, or maybe to like an embedded device. And then you see what is the feedback. And then if there are any changes, you go back to data ingestion again. So this is how the process goes. It's a very, long process. And I think over the years, it has matured a lot. But in general, like in terms of GPT and LLMs, firstly, we will just be looking at model training and model tuning. And why this is important is that, okay, so as a developer or as someone who is trying to use these models, you would already get those pre-trained models. What you would need to do is either fine tune it or figure out how to set its prompts and actually like use it well, right? You already have a pre-trained model in hand. So that is what we'll be focusing on. We won't be focusing much on data validation, processing, and versioning or ingestion. We will tell you how GPT has done it, how these LLMs have done it, but mostly how to take it and use it immediately so that, you can scale it and you can actually deploy something with it. So yeah, this is the main focus. So yeah, this is again something that I took from Karpathi's talk, is GPT assist training pipeline. So what does this mean is it actually has like 4 parts to it. It has pre-training. So pre-training is what we saw in terms of like a pre-trained model. And let me get the pointer here. Yeah, okay. So if you look at here, so pre-training is where the model takes the most amount of compute. So if you see here, it has thousands of GPU, months of training. And it has like, for example, this is what is called the base model. And this is what will build the foundation for us, because we will be looking into base model and then we'll be looking into how to work with the base model. So pre-training is very essential. It's trained on raw internet data. So like trillions of word, which can be low quality, like most of it is low quality, and they're present in very large quantities as well. And what the language is trying to do, as we said, predict the next token, and that's it. And then we move to something called supervised fine-tuning. So supervised fine-tuning is where you have like the model moves from a base model to an assist. So assistant is where you can actually talk to the model, right? When you give it prompts and it's able to give you responses. So that is where the model starts improving. It starts being closer to what humans want it to do. So that is called supervised fine-tunings. That's what SFT stands for. And it requires lesser GPUs than what GPUs are basically. If you don't know GPUs, and I should have introduced it, is basically like, they are like a complex form of our CPU. So our CPUs might process data differently and GPUs process it much more differently. And they have bigger and better computes. So they can actually take away and one of the things that they most importantly utilize is parallel processing. So because of this, it's able to compute data, especially for neural nets. As you saw, it has a lot of, hidden layers, have a lot of like parallel networks going. It can actually use that computation and make it better. And yeah, thank you, Chi. Yeah, GPU stands for graphics processing unit. Awesome. And you can check it out. So NVIDIA, and you'll be hearing a lot of buzz around NVIDIA as well. The fact that, I think now NVIDIA is like the most valued company. It's because of the fact that people are using their GPUs to train LLMs as well, because it's being like, they're the ones manufacturing it. So people are going ahead and using it to its, I guess, like maximum, and people are actually using it really well. So even when you go on the cloud and you use a GPU, it's actually like hosted somewhere, and mostly it'll be NVIDIA or some other form of GPUs that are present. And yeah, and after that, you have something called reward modeling and reinforcement learning. So the last two parts is something that is very, very specific to GPTs, especially ChatGPT, and especially how it was written. So reward modeling is basically, as the word sounds, right? You reward it for every time it does something right. And reinforcement learning is also something similar. You maximize the reward every time it does something right. And so it uses something called reinforcement learning human feedback, which is what is important. And don't worry, I know I'm using a lot of terminologies right now, but I will cover that in detail in the next few sessions. So the idea is that you understand this so that you can deploy your own models. So for the purposes of this session and all, I'll be talking about pre-training, right? What does that mean? And pre-training is something that is not done by you. It's already done. You have the pre-trained model already, but you need to know what it does in the background, so that, if someone does ask you like why you took up this pre-trained model, you can actually go ahead and speak for it, right? So firstly, like if you look at like how Llama is done, because again, we don't know much about GPT-4. We don't know what data it uses. But if you look at Llama, which is like Meta's large language model, so this is the data set they use. They use Common Crawl, which is like a very popular, it has like internet data, and then GitHub, Wikipedia, archive, books. So all of this is a part of their data set, which they use. So a lot of data, right? It's like 3.3 TB alone of Common Crawl. And then what you do is actually you iterate over the model. Now, I don't know if you can see this well, but okay. So in training, what happens is you have to do a lot of iterations to make sure your model sounds well, right? So let us look at this training. Now in this training, what happened was this particular model was actually someone from the New York Times actually tried to train GPT from scratch. And so what they did is they tried to make it give like a Shakespeare poem, right? And or like a Shakespeare verse. So you can see, 1 second. Okay, so after 250 iterations, this is what it sounded like, Well, I mean, the words don't make sense, right? But after 500 iterations, it starts making a little bit of sense. But some of them is like ranter, but I don't know, like it still doesn't sound right. But after 5,000 iterations, so that many rounds of training, it starts to sound a bit more like Shakespeare, I would say, thereof my life and so on. And then once you do 30,000 iterations, you can clearly see it started to make sense of spaces, and it's actually starting to sound a bit like Shakespeare, right? Of gold that breathes forth, thou must like the stars. So it's actually sounding a lot more closer to Shakespeare now. So that is what you do in pre-training. You actually train it a lot more times. You go through a lot more iterations, and that is why you also require that many GPUs. And yeah, and the idea behind pre-training is, and don't get scared by the graphs, all you need to see is that this particular fancy line is actually going down. What does that mean? Is that you want your model to be as close to error free as possible, right? If you wanted to sound like Shakespeare, it should actually sound very close to Shakespeare. And how do you end up doing that? Is that you end up looking at something called the loss function, is the fancy graph here. Is that what they're trying to do is trying to see if the error is reducing. If it started at 3.6, it's actually reducing down here. So that's what they're trying to do. They're trying to make sure the training loss is reducing. And yeah, so finally, like what are base models good at? So when you end up with pre-training, you have a base model. So what are they good at? So they're good at base models can be prompted into completing tasks. They can be, so it can help to make your model look like a document. And so yeah, so for example, this document over here. So here it goes like, how old is Catherine? And they say, and the answer is 54. So yeah, it was able to answer some basic questions, and you sort of trick it into completing a document. So that is what a base model is good at. And base models are not assistants. So that's what you need to realize here, to get it from a place where like a GPT, where you can talk to it and give it prompts and get answers from it. It's moving from something called base model to something called assistants. So base models are basically like, if you ask it to write a poem on bread and cheese, it'll say write a poem about someone who died of starvation, write a poem about angel food cake, and so on. But in essentially, we use something called prompt engineering, which again, like I will cover later on, because I don't want to give you too much information, and also like give you too much at a go, because I know like information should be slow, and make sure it's given like in a broken up manner, so that it's also easily digestible. So like here is a poem about bread and cheese, and you like trick it into performing tasks with prompt engineering, and then it can actually give you better poems. So yeah, what takes a base model to be assistants, right? What does it take for it to be a GPT that you can interact with right now? And that is something that we will cover later on. So for today's session, we are also going to go ahead and look at a few demos, try to see how it performs. Like I know you have like worked with chat GPT, you already like interacted with it, but there are other LLMs that also exist. So I've also put in some other base models that exist. So this is like code gen model. So code gen model is again, like when I talked about, how tuning is done. So this is actually tuned for a specific task for creating programs. Okay. That is written in Python. So when I write like def add two numbers, it actually prints those numbers. It adds the number and it prints it. So it's doing some specific task, right? And let me go back. And then let us look at GPT-2 model. So this is again by Hugging Face. And so I have a cat called Copper. So I give this answer I give this question, should I give my cat Copper a treat? And you see the answer, right? And you can give it some other questions as well and see how it performs. I think we tried this. And you can actually see how far the models have come, right? So this is GPT-2. See? So what is it doing over here? It's a base model, right? So what do you think it's doing over here? That's very surprising. It did not give me Paris, right? But what did it do? It completed the sentence. It said, okay, the first sentence is what is the capital of France? So it said, okay, I'll give you the next sentence. What do the English pay the British? And so on. So in essential, this model doesn't understand, prompts. And that is where prompt tuning, prompt engineering, and fine tuning later on comes also in play, where you try to fine tune it on tasks so that it can answer better when you give it questions. So right now it's just trying to complete the sentence. And this is Coher. Coher is a bit better, wherein like you can write a LinkedIn post. Like you say, write a LinkedIn post about starting a career in tech, and it like gives you a LinkedIn post. And you can play around with its parameters. So these are like some of the models. So you can use like the base model. You can change the number of words that are there, the randomness that's there, and then run it. And then it should be able to give you some other, yeah. So if you see here, this doesn't make sense, right? It says, tell the world the most important lessons you've learned so far. So it's actually trying to complete it. It's not trying to give you an answer here. It's trying to complete the sentence from where it started. So that's what we need to understand about LLMs, that, yeah, you look and you actually interact with a very advanced LLM as ChatGPT. But what it came to be today was through like a lot of these base models. And that's what we're going to discover through the series, is how you can end up, creating like you probably have to use like a pre-trained LLM, but how can you make sure to use it for your specific purpose? How can you fine tune it or use prompt engineering to actually end up using it for your use case and actually building projects around it? And that's what will be useful, right? Yeah, I mean, like you can interact with GPT, but actually using an LLM on your own will still be interesting. So that's pretty much it. But my suggestion is try out other LLMs. Again, I've used some links here, but try out other LLMs and see the difference to GPT. So this is something we'll be talking about next time. So feel free to bring, your opinions on it, and feel free to let me know, like, what do you think about it? Again, like, feel free to let me know your feedback as well about how you felt the session was. If it was too quick, we can go back and we can look at some things again. If there are concepts that need to be, sort of like looked at, we can go ahead and do that as well. And yeah, if you want the slides and content, you can check out something called tinyml.substack.com. So I and Soham have been writing a lot about LLMs, and this is what it covers. And so, yeah, and we have been trying to make some fun graphics too about LLMs. So yeah, this is like one of the graphics we made about ML ops for research labs. And like on the right hand side, it's about vector databases, which is another concept in this. But yeah, and we also talked about what are the hidden costs of actually deploying LLMs and how can you start building products with LLM. So all of this we have covered in our Substack, but I know those are much more technical. So this series, I'm specifically making sure it's like very, very beginner friendly. And again, I've covered today's series, today's like content in like really explained it out well, all the slides in this link as well. So feel free to check it out, and feel free to let me know if you want to contribute as well. This is something we are doing the idea is to make sure we put out content out there and also make sure that it's beginner friendly. So feel free to let me know if you're also interested to put out content and interested to write as such. And yeah, does anyone have any other questions? I hope you enjoyed today, and I hope you learned at least a bit. I hope like if someone stops you on the street and asks you what an LLM is, you can probably answer. You can probably tell us, like, you can probably tell them what it is. Thank you so much.
I think, Archana, it was a wonderful session. We had a small learning shot, like keeping our attention to improve our context length, It was a kind of learning together. So yeah, we had quite an interactive session. And meanwhile, I just have a few things, like if you could clarify that. So one is like, We do use NLP for building chatbots, right? So
Yeah.
how do you associate and transfer the learning to build an LLM-based model?
That's a very interesting question. So yeah, that's where you need to do something called fine tuning, right? So Soham and I were also talking about this before, is that how can you make sure LLMs can actually be used for, I don't know, something like a specific industry, right? So what you do is, LLM has a very large memory. It's been trained on a lot of different wide range of data. So you take that and you actually fine tune it. You sort of get this kid that has just come out of college, and you make sure the kid specializes in something very specific. So if your industry is like manufacturing, the kid will end up knowing manufacturing well. So this model will end up knowing everything about manufacturing well, and then you actually deploy it at the back end of chatbots. So then it can make it like specific to that. So that's why like you have to understand where your requirements are. If your requirements are, for example, making a very generic chatbot, I think you can still do it with like with OpenAI's API. So you get something called the Da Vinci models in the backend, and you can use those Da Vinci models and still like make very simple chatbots, but they'll sound closer to chat GPT, right? But if you needed something very specific to your own industry or your own use case, you have to fine tune it.
Okay. So can you also throw some light on generative AI and LLMs? Like, it's an umbrella term. Can you throw some more information about it?
You know what? I'll let Soham answer for a change. I'm done talking for 5 minutes, but I'll let him answer.
Yeah, sure. So a lot of the models that we have right now, like the common models that we're used to, like ChatGPT, and GPT-4 and all, they are also doing generative AI, right? Like we give them some text and they generate some more text. So I think, but I think your question is like, sorry. Another thing I wanted to add onto that was like there's also generative models doing other tasks. Like for instance, you have Stable Diffusion and Midjourney and all doing image generation. So yeah, so LLMs can be these large models, they can be trained to generate a lot of different things like images, text, and all. Yeah, LLMs are just like a subset of generative models that just generate like text-based stuff. I hope that makes sense.
Yes, it definitely makes sense. Like if we get into the industry specific application, like where it is exactly patched in, then we will come to know about an in-depth understanding of which model to be chosen from the generative AI umbrella. So I would also like to ask a question which has been posted by one of our attendees. Like it was about the data bias that is affecting the output of the model. And for example, the data set to train base model is from Wikipedia, Stack Exchange, and things like that. And we know the majority of the users are male. They are getting the bias thing as well as the usage of your or the data source is also tied up into this question. So do you have any thoughts about it?
Yeah, so I think this ties in with the first question someone asked about data pre-processing. So maybe I'll just answer a bit about that and then go into bias. So data pre-processing, previously, like in the last like decade of ML, a lot of the models, when we feed data into the model, it had to be we had to do some special pre-processing, like let's say stemming, removing punctuations, lemmatizing words, stuff like that. With LLMs and with like transformer-based models, you don't really have to do that anymore. The model itself can take care of pre-processing when it does the tokenization. But the kind of pre-processing that we have to do now is more complex because we now have to pre-process stuff like bias, misinformation. And then, if you have data from sources that are not trustworthy, we have to remove those. So that's the kind of pre-processing that you have to do. And if you don't do that kind of pre-processing well, then that leads to bias in your model. And that can cause problems like the one that the person asked in the question, which is a lot of the users are male. One good way of eliminating bias is obviously using sources of data that we know are unbiased and trustworthy. So for instance, an example I heard is if you're training a model for doing some kind of financial tasks, right? You don't want that model to be trained on data from, let's say, like Wall Street Bets, the subreddit Wall Street Bets. So yeah, so that's a challenge that that the designer of the model who's training it has to take into account. And that's also why there's a lot of issues with these LLM APIs, because we don't actually know the data that was used to train these models. We don't know if OpenAI just took a whole dump of Reddit and fed it into their model, in which case there's a huge possibility of there being a lot of misinformation and bias, right, in the output of the model. So I think these base models, they're really good to build simple MVPs or like POC, like proof of concept applications. But if you want to build something that's good for production, that you would be okay with having other users, play around with, then I think you need to either train a custom model or retrain or fine tune the LLM on data that is trustworthy and unbiased.
Okay, there is an associated question with that. How do you keep the base model? Do you keep it offline or online?
Yeah, so there's a lot of base models of a lot of different sizes. Some of the larger models, like GPT-4, we have models which have more than 100 billion parameters. These models are almost impossible to deploy on your own unless, you can deploy them, but it's going to be very costly if you want to get any good kind of latency or performance out of them. So yeah, so I think right now, the best way to deploy these models is not to deploy the larger models, but to deploy smaller models, which you can deploy in one or maybe a couple of GPUs. And those models you can download from Hugging Face or some other model repository and then run them locally. I think we'll show that in another session.
Yeah, absolutely. Yeah, we do plan to help you build LLM if not products, but at least get them to a point where you can actually deploy it and get something out of it. But yeah, I think one of the questions that I got was from from Veleska, I hope I'm pronouncing it right, and my apologies if I'm not, is that the person asked can you tell us a bit about how you got into LLMs? And that's a great question. So I had been working with NLP before, but again, I recently got into LLMs. Even my learning path has been much more hands-on. I went into OpenAI and I tried trying to figure out how to use their API. And to be honest, my fascination picked up when GPT came out, because I was this has come quite far from where we were in NLP, even 4 years back, right? 3-4 years back, we were nowhere this close to making sense of as even Kirthikka mentioned, when you build chatbots, I remember previously doing with Rasa and all, you had to make sure that the data was really good. It had all sorts of data in it, so that when the person asked the question, you could go ahead and the model could find it in the data itself. And today we've come quite far with large models and large language models as such. So that's what got me interested, and that's where I went and I tried building a product as well. If you want, you can check out our product too. Like this is like something that I also like will talk about in the sessions later on. There's the chat here. But yeah, it's like, we have been using like GPT-4 to build it, and then just basically use like a way to get like, one second, let me add the link here. Yeah, so we've been using GPT to build it, and basically running it on like a Flask app. And maybe we can also talk about how we built it. And most of it is just backend and just making sure it's fine-tuned on this particular task. But it like directly uses OpenAI's API for now. So it's purely built using LLMs or like using this GPT API.
Okay.
Yeah.
That's quite interesting, actually. Yeah. And we are looking forward for the forthcoming sessions of you and Soham to deep dive into LLM algorithms and industrial applications and things like that. We look forward for the forthcoming sessions. Thank you.
Yeah, thank you so much everyone for joining in. And again, feel free to reach out to me with any questions you might have. And I am also on this learning journey, so I totally understand it's overwhelming, and that's why I want to break it down to our community so that a community can, approach this with not more like less intimidation as such, right? So yeah, thank you again so much.
And thank you, community. Thanks for joining us. Please do join for the rest of the 4 sessions, which is hosted at 10 p.m. ET on the same Tuesdays.
This wasn't asked by any of the participants, but I was wondering, maybe you shared a slide on the reinforcement learning and the other one on reward modeling. Maybe you can just share some light on some of the differences, similarities between both of them, since they kind of have that thing of kind of correcting to give reward if, the iterative model. Do you want to share a little bit more about that?
Yeah, I think in the forthcoming sessions, we are actually running out of time, and we will keep that in our pipeline and we'll definitely answer that. And thanks for getting that sheet over here.
Yeah, sure. We'll go ahead and we'll answer that. So that's an entire topic of its own, because RLHF is where like LLMs that you're interacting with, like GPT is, that's where it's specialized. And I would say that's where it's better. And yeah, for sure, I can share like more content on it going forward and make sure that, that's something that people can walk away with, because that's again, like at the core of how it works.
Yeah, that would be great. I'm sure people will enjoy that. We had a slide on it today, so maybe you can shed some more light in a different session. Thank you.
Yeah, absolutely. Thank you, Chi. And yeah, thank you everyone for joining in. I hope you have a great day ahead. Thank you.
Thank you. Bye-bye.
Bye.
Thank you, everyone.